Oh, what's up, guys? We're gonna be going over 5.7 notes. Number one says here, you deposit $4,000 into an account earning 4% interest, compounded monthly. And that's the key right here, real quick. Compounded monthly. How much will you have in the account in 15 years? Round your answer to 2 decimal places. Part one, which equation are you gonna use from the right over here? Well, as soon as you see compounded monthly, or compounded daily, or compounded quarterly, semi-annually, stuff like that, right? That means you are gonna use the second formula. You're gonna be using this formula right here. Right, again, you use that when it says compounded quarterly, monthly, daily, semi-annually, stuff like that, okay? That's the formula you're gonna use, okay? Part two, identify the values in this formula. Use the letter X for the unknown. In other words, all the letters here, you're going to put the numbers that they belong to, like what belongs in those numbers, okay? A is how much money you're gonna have in the future, okay? In this question, it would be how much money you're gonna have after 15 years. That's what this question is asking, okay? Or that's what A is. A is that. How much you're gonna have after 15 years. In this question, we don't know what A is. So A is gonna be X, okay? Now, the letter P is called the principal amount, or you can think about like the payment amount, but you're not making payments in this kind of question, but how much did you pay, right? So if we go back and read the question, the payment here is going to be the 4,000, right? We deposit 4,000. So that is our payment, our principal amount. That's 4,000. Okay? And then R is the interest rate, but not in percent. Okay? So over here it says that we have 4% interest rate. Okay? You're going to turn that into a decimal. If you don't know how, you can divide by 100 or move the decimal 2 to the left. Either way, you're going to get 0.04, and that's going to be our interest rate. N is the number of times you're going to get interest accumulated in your account here. In this question here, it says you're going to be getting interest compounded monthly, okay? And that means that N equals 12, because there's 12 months in a year. So N equals 12. And again, N is 12 again. And T is the time in years. Well, this question said 15 years. So you know all the numbers, okay? So the way you would put it is, I would just write it over here. So in that formula, A is X. That's how much money we're gonna have after 15 years. P is 4,000. 1 is a number, and R, the interest rate, that's 0.04. N was 12, and T was 15. Okay, then you plug in all those numbers, you put them on Desmos, right? On Desmos, you're just gonna type in this pretty much, just all of these numbers here. Put all of that on Desmos, and then it should give you your answer. And then you're gonna round it to the second decimal place, like money, okay? And this question here, it's this one right here. So I'll put all the numbers in there. You might want to verify my answers, make sure I did it right. Okay? If you have any questions on here, ask in class. But again, I just put all the numbers from the formula, I just put them here, and I already have it on Desmos done for us. Okay? So if I round 2 decimal places, I gotta look at the third one to see whether I need to round up. And this question, yeah, 6 means to round up. So the answer here would have been 7281.21. That would be the answer for here. That's how much money they're gonna have after 15 years. Number 2, you deposit $6,000 into an account. Remember, if that's the money you're putting in, that's the P. Okay, I'll do that later. And you're gonna get 8% interest. That's your interest rate. Compounded continuously. Now, compounded continuously, that's gonna be the first formula. This one. Okay, that's compounded continuously. How much are you gonna have in the account after 10 years? Which formula you're gonna use? That's the one I already told you. Part 2, identify all the variables. Okay. A is how much money you're gonna have after those 10 years. I don't know, that's X. P, that's the number, that's the amount you're gonna put in to start with. And that would be 6,000. And then E, you leave E alone, okay? E, remember, E is a number on Desmos. It's 2.71 dot dot that goes on forever, okay? R is the interest rate. And it's 8%, but divide by 100 and move 2 to the left, that would be 0.08. And then you have T. Time in years, 10 years. And then you're gonna plug all those into Desmos, right? Plug them into the formula where they belong, right here. And then you should get your answer, assuming we did it right. And that's what I have right here. Again, it doesn't hurt for you to double check my work, make sure you did it right. Check the third number here. Yep, that's a 5, which means this has to go up. So from 24 to 25. So $13,353.25. So after 10 years, they would have that much money in their account. Number 3. A bank features a savings account that has an annual percentage rate of 3.1%, so that's our interest rate. Compounded quarterly, so here we go, compounded quarterly. Quarterly means you'll be using the second formula. What the heck? There you go. William's going to deposit $2,500 into the account. Okay. How much money will William have in the account after 9 years? But what formula are you using? The one we already have written down. Part 2, identify all the variables. All right, A goes first. A is going to be how much we have after those 9 years. I don't know that number, that's X. Is it always X? No. P is how much we're putting into the account. That's 2,500. R is the interest rate. 3.1, right? But change that. You don't want the percent sign, so divide by 100 again, or move the decimal 2 to the left. That'll give you 0.031. And then R is how much time are we getting interest. Quarterly. Quarterly means N equals 4, because you're cutting the year into 4. Oh, I don't know why I put R twice, my bad. That's N. N equals 4. And then T is the time. 9 years. Plug all that into Desmos. And that's what I have right now. Again, it doesn't hurt for you to check my work. The third one is a 6, so yes, that has to go from 96 to 97. So $3,300, 3,300.97. Okay, number 4. Find the time required for an investment of $5,000 to grow to $7,100 at an interest rate of 5.5% per year, compounded semi-annually. All right, so semi-annually, that means you're going to be using the second formula. So that's the formula we're going to use. Identify all the letters in the formula, right? Okay. A. Do we know how much money we're going to have in the bank after so many years? Yeah. We want the money to go from 5,000 to 7,100. So that's what A is. A is going to be how much money we're going to have in the future. That's 7,100. P is how much we're going to put into the account to start with. That'd be 5,000. R is interest rate, which is 5.5%, but get rid of the percent sign. That'd be 0.055. N is going to be the compounded semi-annually. That would be, you cut the year in half, so that'd be 2 times. And then T in years, well, that's what the question is asking for. The question is asking for how many years is it going to take? So that's our X. All right, so find the time required to do this, right? So first thing I'm going to do is put all the numbers into this formula, okay? Time to write tiny because there's a lot of work here. So A is 7,100 equals P, which is 5,000. Right, 5,000? Yeah, 5,000. Parentheses, 1 plus R over N, and R was 0.055. Over N, that was 2. And then on top, the exponent is going to be N times T, so 2 times X, so 2X. Okay, so this is going to be like the previous notes that I gave you all the last time in class, which I think I made for a video, okay? 5.6 notes. Notice that the X is floating on top. The only way to bring down that X, to bring it down, is to take the log, or ln, right? But we can't do it yet, because I would like to have nothing in the way. Okay, in other words, I don't want, because this 2x belongs to this parentheses, right? These are stuck together. I don't want nothing in front, or nothing after for that matter. The 5,000 is sticking out, it's in the way. So how do you move that 5,000? You know, you don't subtract, you have to divide, because you're multiplying here. So you're going to divide. Divide all of this by 5,000. That cancels. Divide this by 5,000. Now, right here, you can put that in the calculator if you like, but I don't know. I'd rather just keep it like this. So I'm just gonna cancel these zeros. Okay. Again, you can put that on decimals if you like and simplify the fraction, but that's what I'm gonna put. I'm gonna leave 71 over 50. Equals parentheses 1 plus 0.055 over 2 to the power of 2x. Now I want to bring down the 2x, right? I want to bring it down over there. And we can do that if you take the ln of both sides. So take the ln of that. And what's going to happen as a result of doing that this is going to fall down and be right in front of the ln now. So let me rewrite all of this. Equals, but now the 2x is going to be in the very front. And then I got the ln of 1 plus 0.055 over 2. And for those of you wondering, you can put this in Desmos and get a decimal if you'd like. But in the higher level college classes, those decimals go on forever and they don't stop, or they're really weird. So I just leave it like that, okay? It's not that bad. Okay, so what do we want here again? The whole thing we would like is to get x by itself. So I don't want the 2 here, and I don't want all of this here. I want all of it gone. Lucky for us though, what's happening between the 2 and the x? Multiplication. How do you get rid of it? Division. And what's happening between the x and the ln? Multiplication again. So I'm gonna divide everything in one step, watch. I'm gonna leave the x by itself, so I'm gonna divide by 2 and the ln of all this junk right here. I'm gonna do it to both sides. See? So these 2 are gonna cancel each other, and these ln's are gonna cancel also. That's why x is all by itself. That's why we did that. Okay? So what is the answer? This is the answer. But we gotta put that on Desmos, right? And am I gonna round again? Let me say, I forgot to read. Find the time required, round to the nearest whole. So we're gonna round to the nearest year. So instead of going 2 decimal places, we're gonna just round to the nearest whole number. Because the x is t for years, not money. So again, I have that on Desmos. I did that on Desmos. I wanna say this one. Yes, there it is. And that's what I got. Rounding to the nearest whole number. So we got 6, right? But is it 7 or is it just 6? 6, 7. That 4, nope, that 4 is not big enough to make that go up. So the answer is going to be 6. We don't have to put t, but it's 6. 6 years, but the answer is going to be 6. That's kind of a weird question. Not too bad, especially if you understood the notes from last time in class 5.6. Okay, number 5. If $5,000 is invested at 5%, compounded continuously. Oh, we haven't done this one in a while. Continuously. Remember, continuously, that means you're going to use what formula? That's going to be A equals P. Remember that E is just a number. And then exponent RT. Okay. So you're going to put $5,000 into this account at 5%. How long will it take this investment to go to 10,000? Okay. So in this question, do I know what A is? Yes, because I want my investment to grow to $10,000. So I want $10,000 at the end. I'm going to put into the account 5,000 at the interest rate of 5%. That would be 0.05. And then T, that's my X. So I don't know how long it's going to take to get from 5,000 to 10,000. So we got to solve this, right? So A goes first. That's going to be 10,000. Equals P, which is 5,000. And then it's E. And then on top is going to be R and T. And what was R again? 0.05. and then x, because we don't know what t is. That's the time, right? Same thing before. You want to bring this down, but you can't because the 0.05 belongs to the e. And you can take the ln of e, but you can't do it first because the 5,000 is in the way. So move the 5,000, so divide by 5,000 on both sides. That cancels. 10 divided by 5 right there, or 10,000 divided by 5 is by 5,000, whatever. You're going to get 2 eventually. 2 equals e, and then it's 0.05x on top. And we want to bring it down, right? How do you bring it down? By taking the ln of both sides. And when you do that, what happens? This is going to fall down in the front. So let's rewrite it. And then 0.05 goes first. And then if you're a little sneaky clever, hopefully you saw this. What do we have left over? The ln of e. But if you remember from our previous notes, the ln of e is 1. So we really don't need to write it. It kind of went all of it. It just went away. This just went to the number 1. Which is kind of cool. And here we go. So how do I get x by itself? Divide by 0.05. So this is our answer. But of course, you get to round to the nearest whole number because we're talking about years again. So let me see here. This one? Yes. The ln of 2 divided by 0.05 is 13.8. Right, that 0.8 right here makes the 13 round up to a 14. So this would be 14. Well, 14 years, but 14. All right, what number is this? Oh, no. Number 6. So it says here, Fergie deposited 12,700 into an account paying 4.75%. What the heck? 4.75. That would be 4.75, right? Percent. And then I might as well change that already to a decimal. I mean, take away the percent sign. That would be 0.0475. If you get stuck with this, I mean, I hope you don't. But if you did, you could just put 3/4 in the calculator, give you 0.75, and then it's 4.75. You know what I mean? Okay. So I got that. Compounded monthly. Compounded monthly means we're going to be using the second formula on all these pages, right? We'll be using this formula right here. That's the formula we need, right? Copy it, paste it, whatever you got to do. That's the formula we'll be using. Compounded monthly. Monthly means n equals 12. And then this is the interest rate. And then if I'm putting money into the bank, that 12,700, that's the capital P, right? Our principal amount. Assuming no further deposit withdrawals are done, how much will Fergie have in her account in 6 years? So 6 years, that's time. And that's all the numbers you need for the formula, right? And you're going to put into the calculator 12,700 parentheses 1 plus R over N, which is 12, and then 12 times 6 for the amount of years. Now that's too messy for you to understand. I put it on Deadmos. It's right here. There you go. And of course, since we're doing money, you're going to round it. that 9 is big enough to make that 47 go to a 48. So this is going to be 16,878.48. Yep, there you go. And then the next question says, how much interest will Fergie have earned in maturity? In other words, how much interest did did she get, right? Because I mean, she put in 12,700, right? And then she ends up with $16,878.48. So how much did she get interest? Subtract them, right? Just subtract the two numbers together, and that's how much interest she got. That would be this one. Yeah. There you go. I just subtracted them together, and I got $4,178.48, and that's it. All right, this is 6A, and then over here would be 6B. But to be honest, it's the same exact type deal you're doing. Exact same. And Gordon has this much money, right? 12,950. That's our principal. Compounds daily. Oh, daily. That means n equals 365. 6 1/4. That's 6.25%. Right? That would end up being 0.0625. That's our interest rate. How much would he have in the CD after 7 years? And a CD, just call it a certificate of deposit, by the way. It's like a saving. Kind of, but not really. But anyways, 7 years, that's RT, right? How much will he get after 7 years? You just put the numbers in, right? And you're going to put 12,950, then 1 plus R, 0.0625. Divided by n, which is 365. And then up on top, you're going to do 365 times 7 for 7 years. And then whatever that gives you. I don't think I did this one in my notes. No, I didn't. So just put that on Desmos, right? And then you'll get the answer. Whatever you get here, you put that answer that goes there. And then whenever you get the answer that goes there, you're going to subtract it from the 12,950 and that answer that goes here. Okay, and that should be it for the notes.